In this video, we will be going over how to find the volume of a cone. Specifically, we'll take a look at how this is related to the volume of a cylinder. So let's start by thinking about what a cone looks like. Things like traffic cones, ice cream cones, and funnels take this general shape. So if we take a look at our base, we'll see that it's the shape of a circle. Previously, we were finding the volume of a cylinder, which also had a circular base. So when we were finding the volume of a cylinder, we needed the radius and the height. And we're going to need these same measurements for our cone. So the way we would draw this is the radius is just like normal, and then we would draw the height kind of coming up from the center. The relationship here is that cylinders have 3 times the volume of a cone with the same radius and height. So if a cone had a volume of 5 cubic feet, a cylinder of the same width and height would have a volume of 15 cubic feet. So how does this get represented in our formula? We know that the formula for the volume of a cylinder is V equals pi times the radius squared times height. Since a cylinder has 3 times as much volume as a cone, we divide by 3 to get our desired formula. So the formula for the volume of a cone is just 1/3 the volume of a cylinder. Let's do an example. A cone has a radius of 3 feet and a height of 10 feet. What is the volume of the cone? So these are the same measurements from our video on the volume of a cylinder. And if you recall, we got 90 pi feet cubed as our answer. So let's see what we get when we do this with a cone. So first, we'll draw out our shape and then label our measurements. So we have our radius is equal to 3 feet and our height is equal to 10 feet. So then going back to our equation, we have our volume is equal to 1/3 times pi times the radius squared times height. Now we just need to plug in our values. So we'll have 1/3 times pi times our radius is 3 feet squared times our height, which is 10 feet. If we evaluate this, we end up getting 30 pi feet cubed. And this is 1/3 of the volume of the cylinder that we got in a previous video. Moving on to more of an application, a scientist is using a funnel to transfer liquid from one container to another. The funnel has a radius of 5 centimeters and a height of 10 centimeters. How much of the liquid can fit in the funnel at one time? So let's draw our funnel and then label our measurements again. So we have a radius of 5 centimeters and a height of 10 centimeters. Plugging this into our formula, our 1/3 times pi times radius squared times height, we get 1/3 times pi. Our radius is 5 centimeters, so we have 5 centimeters squared, and our height is 10 centimeters, so we multiply by 10 centimeters. And then evaluating this, the 1/3 and the pi just come on down, and then we have 25 centimeters squared times 10 centimeters. So if we plug this into a calculator, we get that this is about equal to 261.8 centimeters cubed. So the main takeaway from this video is that finding the volume of a cone is pretty much the same as finding the volume of a cylinder. What you need to remember is cones only take up 1/3 of the space that cylinders do.